Unit 6. Teaching Generalized Intellectual Skill. Unit Introduction. Some researchers and scholars use the terms critical thinking and higher-order thinking interchangeably, while others define critical thinking as a form of higher-order thinking. Some use the terms critical thinking and problem-solving interchangeably, yet for others, critical thinking is a form of problem-solving. Still others define critical thinking as a part of the process of evaluating the evidence collected in problem-solving, or the results produced by thinking creatively. The elements of reasoning are an extremely useful tool for teaching students decision-making and reasoning skills. The 7 elements of reasoning are purpose and objectives, information, facts and data, assumptions, data interpretation, concepts and theories, points of view and conclusions, implications and consequences. Each element is considered in the reasoning process. Students are taught the framework and its use, and are then encouraged to apply it in real situations. Lessons involving higher-order thinking skills require particular clarity of communication to reduce ambiguity and confusion and improve student attitudes about thinking tasks. Lesson plans should include modeling of thinking skills, examples of applied thinking, and adaptations for diverse student needs. The development of skill is different than gaining knowledge and understanding. Without skill development, it is unlikely that students will be able to effectively convey what they know and understand, and without skill proficiency they are handicapped in their ability to most fully engage content. According to Piaget, the developmental stages are the key to cognitive development. School-age and adolescent children develop operational thinking and the logical and systematic manipulation of symbols. As adolescents move into adulthood, they develop skills such as logical use of symbols related to abstract concepts, scientific reasoning, and hypothesis testing. These skills are the foundation for problem-solving, self-reflection, and critical reasoning. According to Gagné, intellectual skills begin with establishing a hierarchy according to skill complexity. Within this structure, discriminations are prerequisites for concrete and defined concepts, simple rules, complex higher-order rules, and then problem-solving. The 6 intellectual skill development levels of Bloom's taxonomy are also explained in this chapter. Learning outcomes. Upon completion of the unit, you will be able to explain the general principles of intellectual skill, identify factors affecting intellectual skill development in learning chemistry and develop systems to overcome such factors, produce guiding outlines to develop reasoning and proportional skills in science, particularly in chemistry courses. Understand the importance of reasoning and proportional skill development in teaching/learning chemistry. Plan how students learn and solve problems on academic tasks in chemistry. Develop skills of evaluating and assessing students' concept development and reasoning capacity. Discern the importance of developing higher-order thinking skill in chemistry. Section 6.1 Development of Intellectual Skills. Intellectual skills represent the cognitive abilities that enable individuals to interact successfully with their environment and tackle new tasks effectively. Intellectual skill development involves the acquisition of concepts, rules, routines, and symbol systems. Learning an intellectual skill usually means learning how to perform the cognitive processes involved in thinking, reasoning, and problem-solving. Some of the cognitive/intellectual skills of schoolchildren age up to 18 initiates and carries out tasks without supervision. Begin to think in much broader terms, recognizing how things are connected to one another. Begin developing advanced reasoning skills, thinking through multiple options and possibilities. Begins developing abstract thinking skills, considering things that cannot be seen, heard, or touched. Begins examining internal feelings and thoughts. Set goals based on personal needs and priorities. Explores topics of interest in depth. Enjoys playing with ideas. Demonstrates heightened level of self-consciousness. Can handle proportions, algebra, and other purely abstract processes. Begins seeking own solutions, rather than asking adults for assistance. Section 6.2. Logical reasoning ability in student performance. Small group activities such as student discussions, peer tutoring, and cooperative learning can be effective in the development of thinking skills. Activities should involve challenging tasks, teacher encouragement to stay on task, and ongoing feedback about group progress. Giving students support at the beginning of a lesson and gradually requiring students to operate independently helps students develop higher-order learning skills. However, too much or too little support can hinder development at the beginning of the course. Useful learning strategies include rehearsal, elaboration, organization, and metacognition. Lessons should be specifically designed to teach specific learning strategies. Direct instruction, teacher-centered presentations of information should be used sparingly. Presentations should be short, up to 5 minutes, and coupled with guided practice. Activity 6.1. Consider one chapter from Grade 10 chemistry book. For example, electrochemistry. Prepare 15-minute presentation. Make group discussion and form an electrolysis cell from locally available materials. Section 6.3. Proportional reasoning and chemistry. The following are a few of the characteristics of proportional thinkers. They have a sense of covariation, that is, they understand relationships in which two quantities vary together, and are able to see how the variation in one coincides with the variation in another. They recognize proportional relationships as distinct from non-proportional relationships in real-world contexts. They develop a wide variety of strategies for solving proportions or comparing ratios, most of which are based on informal strategies rather than prescribed algorithms. They understand ratios as distinct entities representing a relationship different from the quantities they compare. Proportional reasoning involves the deliberate use of multiplicative relationships to compare quantities, and to predict the value of one quantity based on the values of another. The term deliberate is used to clarify that proportional reasoning is more about the use of number sense than formal, procedural solving of proportions. Students use proportional reasoning in early math learning, for example, when they think of it as 2 4s or 4 2s, rather than thinking of it as 1 more than 7. They use proportional reasoning later, in learning when they think of how a speed of 50 kilometers per hour is the same as a speed of 25 kilometers/30 min. Students continue to use proportional reasoning when they think about slopes of lines and rate of change. Students are using proportional reasoning when they decide that a group of 3 children growing to 9 children is a more significant change than a group of 100 children growing to 150, since the number tripled in the first case, but only grew by 50%, not even doubling, in the second case. Application of numbers in chemistry play an important role. For example, to find the concentration of a solution, you may use a quadratic equation. The solution set for such equation provides 2 answers with positive and negative sign. To report your answer, you must know that negative concentration has no meaning, and only positive must be reported. Activity 6.2. Boyle's law states that pressure and volume are inversely related. As pressure increases, the volume of gas decreases. Discuss with your friends the amount of pressure required to reduce the volume of the gas to 0 value, if applicable. Section 6.4. Teaching higher order thinking skill. In-text question 6.1. What is the difference between critical thinking and higher order thinking skill? The following strategies contribute to the particular kinds of instructional communications necessary for developing higher order thinking skills. 1. Align learning goals, objectives, content ideas and skills, learning tasks, assessment activities, and materials and aids. 2. Establish organized activities and routines. 8. Prepare to ask analysis of the thinking skill to be learned. Identify the particular thinking skill to be learned, the prerequisite knowledge and skills, the sequence of related subskills, and the readiness of students to learn. B. Prepare sample problems, examples, and explanations. C. Prepare questions that go beyond simple recall of factual information to focus on advanced levels of comprehension, such as how, why, and how well. D. Plan strategies for diagnosis, guidance, practice, and remediation. E. Explain and follow established routines, such as starting on time and following the planned sequence of activities. F. Convey enthusiasm, genuine interest in a topic, warmth, and a business-like approach with thorough preparation and organization. Minimal transition time between activities, clear expectations, and a comfortable, non-threatening atmosphere. 3. Explain the task clearly. A. Set goals at the beginning of an assignment. B. Provide examples of finished products. C. Avoid vague, ambiguous terminology such as might, a little more, some, usually, and probably. These terms suggest disorganization, lack of preparation, and nervousness. D. Introduce tasks with a clear and simple organizing framework such as a diagram, chart, preview, or one-paragraph overview. E. Introduce key concepts and terms before further explanation and study. F. Use questions that focus attention on important information. G. Give emphasis with verbal statements, non-verbal behaviors, repetition, and written signals. H. Make ideas vivid with pictures. diagrams, examples, demonstrations, models, and other devices. 4. Give transition signals to communicate that one idea is ending and another is beginning. 5. Provide feedback at frequent intervals with a corrective feedback to clarify incorrect or partially incorrect responses. Activity 6.3. Think about a topic, for example, chemical equilibrium or chemical thermodynamics. Follow the steps given above and practice the steps. Work independently and share with your friends. Higher-order thinking skills include critical, logical, reflective, metacognitive, and creative thinking. These skills are activated when students of any age encounter unfamiliar problems, uncertainties, questions, or dilemmas. Successful applications of these skills result in explanations, decisions, performances, and products that are valid within the context of available knowledge and experience, and promote continued growth in higher-order thinking, as well as other intellectual skills. Appropriate teaching strategies and learning environments facilitate their growth, as do student persistence, self-monitoring, and open-minded, flexible attitudes. Lessons involving higher-order thinking skills require particular clarity of communication to reduce ambiguity and confusion and improve student attitudes about thinking tasks. Lesson plans should include modeling of thinking skills, examples of applied thinking, and adaptations for diverse student needs. According to Nenjamin Bloom, there are 6 intellectual skill-building levels: knowledge, comprehension, application, analysis, synthesis, and evaluation. The following table explains what each level involves and what students do at each level. Unit summary. It is also accepted that as well as being in possession of good critical thinking skills, having intellectual skills as well means that someone must be able to be logical, whilst at the same time apply that logic broadly and clearly, in order to encompass accuracy, credibility, relevance, depth, breadth, precision, fairness, and significance. Critical thinking is a process whereby problems can be recognized in the first instance, so that methods of resolving them can be employed. The importance of prioritizing is understood as is the order of precedence. The process involves gathering relevant information and being able to interpret information and data so that evaluations can be made, and generalizations and conclusions can also become true, after which these can be put to the test. Critical thinking also demands that previous beliefs, judgments, and decisions are not set in stone, and that they can be adjusted as evidence and experience dictate. To develop critical thinking in science, Bloom's taxonomy must be considered while teaching each topic in the class. Assessment mechanism. Consider a topic from high school chemistry, for example, take electrochemistry. Apply the 6 steps of Benjamin Bloom and produce a report. Having your report, you can have group discussion on the topic,